Okay, so now let's move on to the last sum. Okay, so when you will see the question number 10, there are two similar sum like this. Okay, so I will take one sum, the one sum you have to try it by yourself. Okay, so whatever the concept fundamental I will be using, I will be saying here, the same thing you will be you will apply for the next question too. Okay, so here the sum actually it is a little different. When you will see in the numerator here we have two terms, but in the denominator we have three terms, and the format of the question it is like a quadratic equation. Okay, so the sum actually it is a little different here. So here I will explain the adjustment straight away, what exactly you have to do. So here, as first thing we have to guess the formula. Now here, as I told, if in the denominator if you have 1 plus, so here you must get minus. If in the denominator you have 1 minus, so here in the numerator you must get plus. So understood, 1 plus in the denominator, so in the numerator here you must get minus. If 1 minus, if it is there in the denominator, you must get plus in the numerator. Okay, so this adjustment you have to do first. So can you see anywhere 1 plus 1 minus? No, we cannot see anywhere 1 plus 1 minus. So here we have a proper quadratic format in the denominator. But here we can see two terms in the numerator and the connection is minus. Yes. At least we got the idea that in the numerator we have two terms and the connection is minus. So minus, whenever minus it is there in the numerator, whenever minus it is there in the numerator, so we know that which formula will come. That is a minus b upon 1 plus a into b. So which we can write as tan inverse a minus tan inverse b. So at least we got the idea that this sum we have to tackle by using this formula. Okay, now the condition number 1 is what? In the denominator you must get here 1 plus, this is the condition number 1. So we cannot see 1 anywhere, so we have to do the adjustment here. Now see what exactly I will do here, what adjustment I will do here. Just focus. I will keep this 5 minus x as it is for a while. Okay, even I will keep this 6x square minus 5x as it is. I will break this minus 3 as 1 minus 4. 1 minus 4. You can break minus 3 in many ways. Like you can break minus 3 as minus 1 minus 2 also. You can break minus 3 as 5 minus 2 also. But as I told, we required what? 1. Yes or no? We required what? 1. So with plus 1, okay, not minus 1, plus 1. So with respect to plus 1, we have to break, okay. So with respect to plus 1, we require minus 3. So what adjustment here we have to do to get minus 3? It is very simple, minus 4. Yes or no? When you will do minus 4, then only you will get minus 1. So this is the trick here. Just simply you have to break this minus 3. So this is the int here, okay. You must know how to break the numbers, okay. You will keep this 6x square minus 5x as it is, okay. Whenever you see a quadratic equation, just simply you have to break that number with respect to 1, okay. So here what I will do now, see here 1 I will write here, then plus I will keep this part as it is, 6x square minus 5x minus 4. Just check out this 1 and minus 4, you will get minus 3. Yes or no? Okay, got the idea? Understood what exactly I did? Okay, so here you have to break this minus 3. So here minus 3 I wrote as 1 minus 4 because we required 1, okay, positive 1. So with respect to positive 1, you have to break and you must get a minus 3. So which number you will adjust here to get minus 3? It is very simple, minus 4. Okay, so here minus 3 I wrote as 1 and minus 4. There are many ways in which you can break your number, but what will happen when you break minus 3 with any condition, with any numbers, so you will end up with getting your wrong answer. So this is the perfect condition, perfect conversion. You will break minus 3 as 1 minus 4 only for this sum. Okay, for each and every sum, the tricks, the conversion, it will be different. Okay, so but for this sum minus 3 I will break with respect to 1 minus 4. Okay, so now after this what I will do, as clearly we can see that we'll consider this whole part as one term. This is 1, and here we have plus, here we have minus. So now at least we got the idea that we have to solve, we have to tackle this sum by using this formula. Yes or no? So we got 1 plus 1 plus 1 plus, okay, 1 plus. Now I will take this quadratic equation separately. Now see here what I will do. I will take this quadratic equation separately, and I will solve this quadratic expression separately. I will solve this quadratic part by using splitting of middle term. Now we'll see what exactly you will get. The two product, final answer, two answer. Okay, so here the product is what? 6 minus 4. So that means the product is what? 24, minus 24. So the product is minus 24. So here we require minus 5. So we can write it as minus 8 into 3, you will get minus 24, and minus 8 plus 3, you will get what? 5. So we can break this minus 5 as minus 8x plus 3x minus 4. I hope all might be knowing how to solve the splitting of middle term. Okay, so after this, here clearly we can see that the common is what? The common is 2x. So inside the bracket we will get 3x minus 4. Here we cannot see any common, so we can write as 1. So inside the bracket we will get 3x minus 4. So the next step, 2x plus 1 you will write in one bracket, and 3x minus 4 you will write in second bracket. So here what I did, I will keep this part as it is for a while. Okay, so we had solved the quadratic equation, so where we got the answer, one part is what? 2x plus 1, and the second part is what? 3x minus 4. Okay, so can you see in the denominator, this section, it look like what? 1 plus a into p, 1 plus a into p. So here if 1 plus it is there, so here we require minus, and here it will be a and p. Okay, so when you will solve, when you will subtract this two part, when you will subtract this two part, you must get this numerator. Yes or no? So this is the concept here. So now we'll see after subtracting whether we'll get this answer or not. Okay, now we'll check whether we are getting this answer or not. Which part? This two section, this two part. Okay, let's see when you will subtract this two section, 2x plus 1. Let's see whether we are getting the numerator part or not. So bracket open, minus 3x plus 4. Okay, so here 1 plus 1 plus 4, you will get 5. 2 minus 3, you will get minus x. Yes, we are getting the numerator. Yes or no? So here we can write this 5 minus x as what? 2x plus 1 minus 3x minus 4 upon 1 plus 2x plus 1 into 3x minus 4. Okay, so this is a, this is b, and this is a minus b. Yes or no? Okay, so I hope you understood what exactly we did for this sum. So it is very simple. Just simply what you have to do, just see the quadratic equation. Okay, break this number minus 3 with respect 2 plus 1. Okay, then after that you will solve this part, this quadratic equation, by using splitting of middle terms. So where you will get 2x plus 1 and 3x minus 4. Okay, so clearly we can see that in the denominator we are getting 1 plus 2x plus 1 and 3x minus 4. So here we have 1 plus. So here in the numerator you must get minus. Minus what? A minus B. So we'll consider this as A and this as B. So here A is what? 2x plus 1 and B is what? 3x minus 4. Just check out when you will subtract this two term whether you are getting 5 minus x or not. If you are getting 5 minus x, so this adjustment is perfect. Got the idea? Okay. So this is what we have to do for this sum. So this sum, it is little different. Okay, and it is a proper 4-mark sum at this very important sum. Okay, and see to that this part, quadratic equation section, you can solve on the right hand side. This section there is no need to show in the step. Okay, quadratic part there is no need to show this step in the sum. You can solve this quadratic section separately, find out the answer. Okay, find out the answer. So here we got this two product, and then check out after minus whether you are getting the numerator or not. Yes. So just now what I did, I converted this question in this form, and this form actually it is in the form of tan inverse. When you will say tan inverse, it look like a minus b upon 1 plus a into b. Yes or no? So which we can write as what? Tan inverse a minus tan inverse b. Yes or no? So I hope you all understood this adjustment, and see to that this is one of the important sum from the exercise. Okay, don't skip this sum. Okay, it may will come in the next board exam. Okay, so when you will see the previous board papers, you will see this sum repeatedly. It is coming from so many years. Okay, so this is the one of the important sum from the exercise number 1.2. It is a proper 4-mark sum. So after this, what exactly we have to do when you will apply this formula? So here you will get tan inverse 2x plus 1 minus tan inverse 3x minus 4. Okay. So now adjustment over. So now we can find the derivative with respect to x. So derivative of y, we know that it is dy by dx. Tan inverse derivative also we know that it is 1 upon 1 plus x square, but here clearly we can see that x is replaced by some other term. What is that part? It is 2x plus 1. Yes or no? 1, again you have to use the derivative of tan inverse. It is 1 upon 1 plus x square into x is replaced by some other term, so that will be 3x minus 4. Okay, so in the next step, this will be dy by dx will keep as it is, 1 upon 1 plus this part. When you will say it look like a plus b the whole square, but see to it that don't solve this sum further, don't expand this sum by using the formula a plus b the whole square. Keep the part as it is, because when you will see the backside answer, it is till there only. If suppose if you extend one more step, it's okay, no problem. Okay, still you will get full marks. Okay, if you do some 2-3 extra step, it's okay, but don't reduce your step. If you reduce your step, you will lose your marks. Okay, so derivative of 2x plus 1. So 2x plus 1, there are two terms and the connection is plus. So derivative of 1 will be what? 0, and derivative of 2x, it will be what? 2. 1 upon 1 plus, we'll keep this part as it is. Okay, don't solve this part by using a minus b the whole square. Okay, so here also same, there are two terms. Derivative of 4 is 0 and derivative of 3x will be what? 3. So in the final step, 2 plus 0, it will be 2. So we'll write this as 2 upon 1 plus 2x plus 1 the whole square minus 3 upon 1 plus 3x minus 4 the whole square. So that's the end of the exercise and even the sum also. So there is one more similar types of sum in the exercise number 1.10. It is the last sum. When you will see the question number 10, it is the last sum. But the same sum, same fundamental, same trick, same technique you have to use. First, you have to break that number with respect to 1 and then see to that which formula will come, whether you have to solve that sum by using first formula or by using second formula. So in short, question number 10 is what it's all about. Just that two formula, tan inverse a plus b and tan inverse a minus b formula, that you have to guess. Okay, so the guessing is very simple. Which formula will come? Okay, in the denominator, suppose 1 plus it is there, so your minus will come. In denominator, suppose 1 minus it is there, so your plus will come. Okay, so this here it will be a, here it will be b, here it will be a into b, a b, a into b. Got the idea? Understood? Okay, so this is all about the question number 10th. Okay, so as now we had covered all the sums, all the concept based on the exercise number 1.2. As I told, exercise number 1.2 compared to all the exercises is very easy, very simple. Okay, just to reduce the step, you must know all the basic formulas of your 11th standard. Okay, so that basic formula is what? Actually here in this exercise, it is the adjustment section, adjustment part. Okay, so here you have to do the adjustment in this exercise. You have to do the adjustment with respect to your basic formula of your 11th standard. Okay, so I hope you all understood all the sums of your exercise number 1.2. As now we had covered all the sums, all the major sums, all the important sums from the exercise number 1.2. So that's the end of the exercise number 1.2 as well as the whole section, whole chapter. Okay, so I had covered all the sums, all the concept, all the major sums, important sums, board point of view also. Okay, so there are 2-3 theorems in the chapter. So that after that, in maybe in between, I will give the theorems also. Okay, just theorem, you go through the theorem, you will come to know exactly what we have to do. Okay, and just theorem, you have to practice that theorem for 2-3 times. Okay, because in the derivative there are 2-3 very important theorems. It may or may not come for may or may not will come in the board exam. Okay, but each and every theorem, it is a proper 4 marks. Okay, so there are 3-4 theorem, important theorem. So afterwards we'll see what all the theorems are there, the important theorems which we have to do for the board exam. So here now that's the end of the exercise as well as the chapter. Okay, so in the next, from the next lecture, we're gonna see a new chapter. Till then, goodbye. See you in next lecture. Okay, so watch this video one more time. The sounds based on the exercise number 1.2. So already I had uploaded the videos on my YouTube channel. Even I will share the link in the Google Classroom also. Okay, so till then, goodbye. See you in next lecture.